Hello, this is Unit 5, Lesson 4, and in this lesson we're going to be learning how to write quadratic equations if we from the sum and products of our solutions. Sorry, yes, the bells still go off even though you guys are in school. Anyway, so we had talked briefly in our first lesson of this unit how to write the equations given the solutions if we change them to factors and FOIL those out. So this is just another method that we can use. It also helps us explore the relationship between the A, B, and C values in our quadratic equation and where all those numbers come from. All right, so let's get started, and just a special shout out to my regular viewers. All right, so taking a look at our quadratic equation, if we look right here, remember this is the standard form, ax squared plus bx plus c. Okay, that's your quadratic equation in the standard form, where a, b, and c represent values. And we know that sometimes certain values are missing. For example, if you are looking at a difference of perfect squares, we don't have the b term. And sometimes when you have x squared, we have a coefficient there that's 1, and sometimes we have a number, and sometimes your constant doesn't exist. So just keep in mind that even if you do have an equation where some factor or some value is missing, like for example, let's say a 5x squared plus 10x equals 0, we don't have a constant there. We don't have a c term. Really, our c term is the value of 0, okay? If a b term is missing, the b value is 0. I just want to point that out because as we've been going through and learning different methods and how to solve quadratics, that question has come up. Well, what happens if there's no b value? Then b is equal to 0, okay? All right, so taking a look. So looking at it, it tells us that if S1 and S sub 2, just standing for the different solutions, they're solutions to our quadratic form, then the sum of the two answers, and that's what we mean by solutions, you solved your quadratic, you got two numbers, the sum of those values would be the same thing as negative b over a. And the product, so this one is our sum, the product is the same as c over a. So we can use those two numbers to help us to work backwards and write the actual equation. Now, when you do this, if you add the two numbers together and you get a whole number here, and you multiply them together and you get a whole number, that's telling you that your a value is 1. And you'll see what I mean by that shortly, okay? So looking at looking at our quadratic equation, we can go ahead and just use this concept to plug in our b and our c values. And we'll deal with what happens if you do have an a value shortly. Okay, so look at this example down here. It tells us that the real solutions are 4 and negative 5. And once again, we talked about how we could change those to factors and FOIL it out. So that's one method. But we can also use the sum and product method. You just have to remember that the sum of the solutions is going to give you the middle term and the product is going to give you the last term. And if you really think about it, you already knew that because whenever we're working backwards and going from the quadratic and factoring, we're doing a times c, finding factor pairs, two numbers that multiply to c, that add up to b, that give you the sum. So you kind of already knew this. You just probably didn't think of it this way, that we can work backwards to go from the answers to the quadratic. So in this example right here, we're saying that the quadratic equation has, once again, the solutions of 4 and negative 5. So if you notice, I added them in here together. Okay, 4 plus negative 5 gives me negative 1. Now, keeping in mind that the sum is negative b over a, so it's negative of whatever that value is. So notice how my double negatives made a positive right here. All right, and then the product of the two gives me my c value. So 4 times negative 5 gave me negative 20. All right, well, what about a? We'll talk about that in example number 3 when it really comes into play. Okay, because in this example, it is an a value of 1. Because think about it, guys. When you added the 4, you did the negative of 4 plus negative 5. All right, that gave us negative 1. So those are positive. Your value when you add the sum is negative b over a. Okay, so I've got this positive 1 over 1. So my a value is 1. When I multiplied the two together, I got negative 20 over 1. Okay, this number up top is your b. This number up top is your c. The number on the bottom, which hopefully is the same, is your a. Okay, and we'll talk about what happens if it's not shortly. So that's why there is no coefficient in front of x squared besides 1. All right, looking at example 2, we can do the same thing, write our quadratic equation that has the real solutions of 3 and negative 7. So if I worry about the sums first, all right, I'm just doing 3 plus negative 7, 3 minus 7, which gives me a negative 4. If I do the products, 3 times negative 7, which gives me negative 21. So please just be careful, because when you are substituting those two values in, make sure they're going in the correct spot. The sum is in the middle, the product's at the end, and make sure that the sum goes in as the opposite, right? So it's opposite of that, right? So then when I simplify it, it's really x squared plus 4x minus 21 equals 0. Okay, once again, because my sum and product both had a denominator of 1, I didn't have to worry about an a value, or that's telling me my a value is 1. All right, so let's take a look at the next example. In this one, you'll notice that, hey, we have fractions. Okay, so that's going to come into play here. So when we find the sum, we do need to find a common denominator, okay, because we're adding them together. So I'm going to go ahead, and I know I'm going to want a common denominator of 6. So I'm going to do that over here. So 2 times 3 was 6. So 1 times 3 is 3. And this is 6 as well. So 3 times 2 gave me 6. So 2 times 2 gave me 4. So the sum is 7 over 6. The product, when I multiply them together, multiply my numerators, which gives me 2, multiply my denominators, which gives me 6. Okay. So now when I plug it into my equation, we have x squared minus 76x plus 2 over 6 equals 0. Now let me ask you this. How often do we actually see quadratics that have fractions in them? Not often. I mean, we can have it. Fractions are numbers too. But what we want to do is we want to write this with integral coefficients. What do I mean by integral coefficients? Let me write that out so you can see the words and give you an idea if you're not sure. Integral meaning integer. We want integer coefficients. We don't want fractions. So how are we going to go through and get rid of that denominator of 6? Okay, now notice they are both the same denominator, and if they weren't, we're going to use the same process. We just got to clear out a denominator, but we want to multiply by what's going to get rid of it. So I'm going to multiply everything by 6, not just the coefficients that have a denominator, because whatever you do to one term in one side, you've got to do to everything. So everything's getting multiplied by 6, which gives me the 6x squared minus 7x plus 2 equals 0, because 6 times 0 is 0, so that stayed the same. Okay, so by multiplying by that, I cleared out the denominator. And if you notice, guys, in both of these, I have 6 down here, because look, we said that the a value is the denominator if there is one for both your sum and your product. So if you saw that, that's what's happening. You could have realized that that's why. Okay, when I multiplied through by the 6, that gave me my a value. All right, so that is writing the quadratic equation given this using the sum and product concepts. All right, if I give you the real solutions, you can work backwards and give me the other. Now, something I want to show you is you can also go the other way. If I give you a quadratic equation, and we'll do 2 examples. I know it's not on your sheet, but let's write it down. Okay, and then my second example, I'm just going to put numbers here. Okay, so if I give you the quadratic, you can work backwards and actually tell me what the sum and the products are. All right, so remember, the sum is going to be negative b over a, and our product is c over a. This is the sum of the 2 solutions and the product of the 2 solutions. Yes, we could actually go ahead and solve them and find what the sum and product are, but keep in mind we don't have to go through that whole process. So for this one, since a is 1, it's pretty straightforward. The sum is going to be negative 12 because it's the opposite of b over a. So it ends up being negative 12 over 1, or negative 12. And the product is just 120 over 1, so 120. All right, I'm just pulling out my a, b, and c value. Over here, my sum is going to end up being negative 4, or positive 4, over 3. And then my product will end up being, sorry, that's a plus 5, 5 over 3. Okay, so if we actually did solve them, we could prove that and add the two solutions and multiply them to make sure we do get those values. Okay, so that's how sum and products can help us identify what the equation is and how to work with the solutions. All right, we are all done.